Okay, hello everyone. Today we're looking at how to find missing angles inside of right angle triangles using trigonometry, or in this instance, SOHCAHTOA. Now you can only use SOHCAHTOA for angle questions dealing with right angled triangles. Now in front of us we have a right angled triangle that's been labeled with our three key lengths: the hypotenuse, the opposite, and the adjacent. And a quick review as to how you label this: the hypotenuse is always the longest length and it's always opposite the right angle. Now, the opposite and adjacent depend on the position of the angle you are working with. Over here, this is the angle we're working with, so our opposite is the angle which is opposite that length, which is over here. If the angle had been this one instead, this would have been the opposite. So it does depend on the location of the angle you're working with. Finally, the adjacent is the last one that's left, and adjacent just means next to. So that is the length that is next to the angle. That isn't obviously the hypotenuse. It's not the longest, it's the other one that's next to the angle. And then we come across our three formulae, or our three identities in this case. We have sine of an angle is always the opposite divided by the hypotenuse. Cos of the angle is the adjacent divided by the hypotenuse. And tan of the angle is the opposite divided by the adjacent. When you come to your questions, you'll be using these lengths to enable you to figure out which formula you need to use. So I've got three questions coming up, all slightly different, but just to give you an understanding of how to tackle questions like this. Now we have three here, but they all follow the same general layout. You'll notice in the first question we've got lengths with 5 centimeters and 12 centimeters. Second question has lengths of 2 centimeters and 30 millimeters, and the last question has three lengths of 3 centimeters, 4 centimeters, and 5 centimeters. And all of these are slightly different, but we still follow the same layout for these questions. The first thing is always to label the diagram, label your lengths onto it. So let's start with the easiest one, which is always the hypotenuse. The hypotenuse is the longest and opposite the right angle. Now you'll notice that I'm just writing h from now. I don't need to write down HYP because we know h is for hypotenuse, O is for the opposite the angle, A is the 5 centimeter length, and we're left with the last one, which is adjacent, which is the 12. Now for this question, we need to see which lengths we are using, which ones we have. We have the adjacent, we have the 12 centimeters over here, and we have the opposite, which is the 5 centimeters. Therefore, we need to see which formula has opposite and adjacent in it. So let's come to our formulae on the right hand side. Sine has opposite and hypotenuse, we don't need that one. Cos has adjacent and hypotenuse, we don't need that one. Tan has the opposite and the adjacent, so that is the one that we will be working with. That means that tan of the angle, which in this case is A, is equal to the opposite divided by the adjacent. I always label the formula first. I make sure that we have the proper formula. We then substitute in tan of A is equal to the opposite, which was 5 divided by 12. Now 5 divided by 12 as a value is equal to 0.416 recurring. Now that's not an angle, we need an angle value. And to find that, that's A, not tan A. To find the value of A, we have to use what we call the inverse tan function, which is tan minus 1. Now this is a function on your calculator. It's the opposite or inverse of tan. If we come to a calculator, we can see you have sine, cos, and tan. But just above those, you have in yellow shift sine minus 1, cos minus 1, and tan minus 1. Those are the inverse functions, which we use when you're working out an angle. Now, they're also known at A level as arc sine, arc cos, and arc tan, but it's not something you need to know at GCSE. So if we go shift tan 5 divided by 12, we get a value which is equal to 22.6 degrees. So that means that angle A in this case is equal to 22.6 degrees. And that's done. Fantastic. Completely sorted. Okay, so let's move on to the next one. Now, the next one has an issue already within the diagram. Have you identified what it is? It is the fact that the lengths are not in the same units. If you are going to tackle a question like this, because these sine, cos, and tan are effectively ratios, when you write something as a fraction, you can also write as a ratio, you need to make sure the units are consistent. So for that, I am going to change the 2 centimeters into millimeters. There are 10 centimeters, 10 millimeters in a centimeter, so that gives you 20 millimeters over here. And now we are consistent. I've done that in green because actually that length there from B to there is our opposite. And the 30 millimeters in this case is our hypotenuse, which means that we are missing for this length, sorry, for this triangle, the adjacent. We don't need to find the adjacent, but we can if we want to. It's not what we need. We need the angle. So we're working with, in this case, O, 2 centimeters or 20 millimeters. And we are also working with the 30 millimeters, the H, that's O and H. Bring it to our formulae on the right hand side. O and H is sine, very, very first one. So we write down our formula. Sine of B is equal to O divided by H. When we substitute in, sine of B is equal to, the opposite is 20 divided by 30. Now we said to work out the angle, 20 divided by 30 is 2/3 or 0.6 recurring. That's not an angle. We need to find out the value for B. B is going to be the inverse function, sine minus 1, 20 over 30. And if you work that out on your calculator, once again, so bring it over here, shift sine 20 divided by 30 is equal to 41.8 degrees. So that angle there, B, was 41.8 degrees. So we have there second triangle done. Now we come to the last one. The last one's a bit different because we're actually given all 3 lengths. But actually, what this means is you can use any of your 3 identities. If we label the triangle, we have over here H. Opposite is always opposite the angle that we are looking for. Angle we're looking for is this one over here. That's our opposite. And therefore the adjacent is the 3. So we said we could use any of our formulae, any identity. We have O, A, and H. For this one, I'm going to use the identity we haven't used yet, which is cos. For cos, we need to use the adjacent, which is this one, and we need to use the hypotenuse, which is this one. And what we can see here is if we are using cos of x, sorry, cos of c in this case, is equal to the adjacent divided by the hypotenuse. That means we get cos of c is equal to 3 divided by 5. C is cos inverse or cos minus 1, 3 over 5. And if we substitute that into your calculator, once again, shift cos 3 divided by 5 is equal to 53.1. So C, the angle C, is equal to 53.1. Now, if you don't believe me, you could try a different identity. You could use tan. Tan is the opposite divided by the adjacent, which is 4 divided by 3. If we do shift tan, 4 divided by 3, so using a different identity, we would have gotten Same thing, 53.1. So we said it does not matter which identity we are using here, they will all give you the same result. I hope that's made sense. If it hasn't, please comment below or let me know.